So this will be the second half of the Lewis dot structure video. So again, I did several examples. I did 3 examples, and we're just going through these steps. So let's just pick up where we left off. And again, feel free to hit the pause button as you're doing things and try these on your own. So we did ammonia, a methane, and water. Now let's try carbon dioxide. These are some molecules we're going to talk about later too as we progress. All right? So same approach though. Step 1, determine the total number of valence electrons. So make a list of the elements. Carbon is in group 14, 4 electrons. Oxygen has 6 electrons. From the formula, there's 1 carbon and there's 2 oxygens. That means there's 4. That means there's 12, 6 times 2. And that means there's 16 electrons divided by 2. So this one's going to have 8 pairs. All right, let's just kind of put a line there so we can kind of keep track of things. Now, central atom, well, it's not, there is no hydrogen, but so we look at the other rules. Well, the carbon has the fewest valence electrons, the carbon is less numerous, and the carbon has the least attraction for electrons. So we're going to put the carbon in the middle. Go like this, O, C, O, like that. Now we determine, so that's step 3. Now we determine the remaining pairs. So my remaining pairs, there were 8. I've used 2. That means I have 6 pairs of electrons. I still have to put in this structure. Now where am I going to put those 6 pairs in? So let's redraw this. Now I'm going to put those 6 pairs in. All right. Now step 5 says we put them as unshared pairs on the outside atoms until they're filled. So we're going to put them on the oxygens. 1, this is how I do it. 2, 3, 4, 5, 6, and now the valences are filled. Remember, you stop when you have 4 lines touching it. Now the carbon's not done, but we're not there yet. Let's check that we have indeed 8 pairs, because at the end of this step we should have everything in the structure. We have a carbon and 2 oxygens, and we should have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. So everything's in the structure. So now let's check the valences. The oxygen has 1, 2, 3, 4 lines. The carbon only has 2 lines, and the oxygen here has 4 lines. So we can't just draw 2 more lines because we don't have those, right? We've got all the pairs in. So this is where we're going to go to step 7. If there's a deficiency, we're going to convert an unshared pair on an outside atom into a bond to the deficient. So let's just arbitrarily, let's take this guy here and let's make it into a bond. The carbon is deficient. So I'm going to redraw this up here just so you can see what I've done. So now I redraw it. So that oxygen now only has 2. This bond, this unshared pair is now a bond to the carbon. This side we didn't do anything to. And again, I recommend that you, every time you make a change, redraw it so you can see what you've done. We still only have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Right now let's check the carbon, oxygen has 4. Carbon is better, it has 3, this oxygen has 4. So what should we do? We're going to do it again, but now let's take it from this side. We want to be symmetrical. So now, my new structure, okay, this side we didn't change. But this side, right, we took that one from the bottom. It doesn't matter which of the pairs you take. So now let's check. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Everything has 4. I'll write it down for you. And you'll notice we only have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. This will blow your math teacher's mind, right? 4 plus 4 plus 4 equals 8. Anyway, that is the Lewis dot structure. And you can see we've got unshared pairs of electrons. And I'll tell you right now, unshared pairs of electrons are very important to the chemistry of these molecules. Also, the fact that it's double bonds versus single bonds is important to the chemistry. Okay, let's do, I'm going to do 2 more, just because I said I would do this many. Let's do, actually I'm going to do one that I wasn't going to do, that I didn't in my notes to myself. Let's do, SO2, no, let's do ozone. We'll do ozone, and then we'll do SO3 later on. All right, so ozone's cool. I thought this is nice because we're going to talk about ozone later. There's an oxygen, there's 6 electrons, right? And there are 3 oxygens. That means there's 18 electrons over 2 is 9 pairs. All right, this one's obvious what's going to be in the middle because it's oxygen, oxygen, and oxygen. So now we had 9. We'll do this a little bit more quickly now because we've done some of these. 9 minus 2 is 7 pairs. So those 7 pairs are going to go into this structure. And where are we going to put them? We're going to put them on the outside atoms. 1, 2, 3, 4, 5, 6. But I can't put the 7th one on the outside atoms. So now I'm going to go to the central. And you see it says if there's a deficiency, convert an unshared pair on an outside into a bond to the deficient. All right, now let's count. 1, 2, 3, 4. 2, 3. 1, 2, 3, 4. So what are we going to do? We're going to take one of these here, doesn't matter which. Whoops, didn't mean to do that. All right, and convert it into a bond to the central. We could have done it from either side. Just so you can see what I've done. Let's check it. So now we've got that, a double bond now, because we took this pair and made it into a bond. This one we left alone. And you can see 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and we only have 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the Lewis dot structure of ozone. And we're going to do a whole unit where we're going to talk about ozone. Not a whole unit, a short set of slides actually. All right, let's do one more. Then you should have enough to do the homework, and it's just a practice thing. I can't stress enough though, make yourself go, you see how I'm doing every step? I'm making myself go step by step. Don't just start drawing symbols and lines. Okay, why don't you try this one on your own? So hit pause and try it on your own. All right, and then you can come back and I'll walk through it. So I'm going to keep going. I'm going to count to 3. 1, 2, 3. All right, so hopefully you're back from pause. Hopefully you tried it. So let's see how you did. All right, so step by step. We have sulfur, we have oxygen. We have 6 electrons in sulfur. Again, get this from your periodic. You should have a periodic table on your wall by now. There's 1 sulfur, there's 3 oxygens, so there's 6 electrons here. There's 18 electrons here. That means there are 24 electrons. Divided by 2, that means there are 12 pairs of electrons. Looking at this, what's going to be in the middle? It's going to be the sulfur. So we'll go S. I'm just going to put them to the corners of a triangle. You can do whatever you want, but I just do it that way because I have it. All right, I try to go symmetrical. So my remaining is 12 minus 3 bonds. That means I've got 9 pairs left. So where are these 9 pairs going to go? We're going to put them on the outside atoms. All right, so let's put them on here. 1, 2, those are bad looking O's. 3, 4, 5, 6, 7, 8, 9. Double check that you have indeed 12 pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you don't have 12, you don't have 11, you don't have 13. Okay, now we're going to check the valences. The oxygen has 1, 2, 3, 4. This oxygen has 1, 2, 3, 4. This oxygen has 1, 2, 3, 4. And the sulfur has 1, 2, 3. All right, that means what are we going to do? Doesn't matter which one we do it from. We're just going to take a pair of electrons and do this. So let's redraw it here, just so you can see, because it looks like it might be done. So this one we left alone. This one we left alone. Again, it's arbitrary which oxygen I take it from. There's other concepts here that we don't need to do in Chem 111. Right? We turn this one into the bond. So now we're going to check again. 1, 2, 3, 4. 1, 2, 3, 4 on the sulfur. 1, 2, 3, 4 on the oxygen. 1, 2, 3, 4 on that oxygen. Right? So there you go. That's the Lewis dot structure. There's only 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just so you can get a better look at it, I'm going to erase the 4s. Whoops. All right, so you can see that's the Lewis dot structure of sulfur trioxide. All right, so I went through 6 examples. That should be enough for you guys to get some good practice with this. So you should be able to do a lot of homework for. I'm going to do one more thing with the shape, and that'll be the last thing we do with this set of material. All right, and that'll get you through homework 4. But that's a good feel for how to draw Lewis dot structures. I can't stress enough, follow the instructions. Make yourself go step by step. All right, good luck.